This section's title tells us we're dealing with a quiz about tuning the hyperparameters of the Sklearn. GraphicalLassoCV estimator. We'll be figuring out the correct way to use cross-validation. This section lays out the core problem. I'm using GraphicalLassoCV to build a sparse inverse covariance matrix. This is a fancy way of saying I'm trying to figure out how different variables are related while keeping the model simple. The question will test my understanding of how GraphicalLassoCV's cross-validation parameter, (CV) works. This statement says that setting (CV) to 5 means we'll use 5-fold cross-validation to find the best value for the regularization parameter. Alpha controls how sparse our inverse covariance matrix is. 5-fold cross-validation means the data will be divided into 5 parts. 4 parts will train the model, and the 5th will test it. This process will be repeated 5 times to ensure a robust model. Here, we are told that using (CV equals none) disables cross-validation. This means that instead of automatically finding the best alpha, I need to manually provide it. This statement claims that (CV) only accepts integers. I will show this is incorrect. The (CV) parameter is more flexible than that. This is the statement that cross-validation, (CV) greater than 1, usually helps create a better model because it helps avoid overfitting the training data. Overfitting means the model learns the training data too well and doesn't generalize well to new data. These are the steps I will take to solve the problem. First, I'll examine each statement carefully, then I'll consult the Sklearn documentation, although it's not explicitly required here. This section indicates that statements A, B, and D are the correct answers. This is a summary of the correct answers. This phrase introduces the topic of the quiz. We're going to be tuning the hyperparameters of the GraphicalLassoCV model in Sklearn, a library used for machine learning. Think of hyperparameters as settings that control how the model learns. We're specifically focusing on cross-validation, which is a technique to find the best hyperparameter settings. It's like fine-tuning a recipe to get the perfect taste. This is the central question of the quiz. It asks you to identify true statements about how the (CV) parameter, short for cross-validation, in the GraphicalLassoCV function works. We'll examine each statement carefully. Statement A describes how setting the (CV) parameter to 5 performs 5-fold cross-validation. This means the data is split into 5 groups, and the model is trained on 4, then tested on the remaining 1. This process repeats 5 times, each time using a different group as the test set. The best (alpha) value is chosen based on the average performance across these 5 tests. (alpha) controls the sparsity or simplicity of the model. A lower (alpha) means a more complex model. Statement B explains that setting (CV) to none turns off automatic cross-validation. You would then need to specify the (alpha) value yourself. Think of it as choosing the recipe ingredients directly instead of letting the system find the optimal combination. Statement D says that using cross-validation, (CV) greater than 1, generally improves the model. It produces a more reliable estimate of the precision matrix, reducing overfitting. Overfitting means the model is too closely tuned to the training data and performs poorly on new, unseen data. Cross-validation helps to prevent this by evaluating the model's performance on unseen data. Statement C is incorrect. I found that the (CV) parameter is not limited to integers. It can accept other ways of doing cross-validation, not just a simple number of folds. This section would outline the steps involved in cross-validation, however, the provided text does not give a step-by-step description. This section introduces the core problem, determining which statements about the (CV) parameter in GraphicalLassoCV are correct. I'm focusing on the (CV) parameter within Sklearn's GraphicalLassoCV function. This parameter controls how cross-validation is used to find the best regularization parameter, (alpha). Cross-validation helps prevent overfitting by testing the model's performance on data it hasn't seen before. Let's dive into the question about how GraphicalLassoCV uses cross-validation. We will assess the validity of 4 statements related to its behavior. This statement is incorrect. I found that the "CV" parameter isn't limited to just integers. You can also use other scikit-learn cross-validation methods like "kfold" or "stratified kfold", or even provide a pre-made cross-validation iterator. This is entirely correct. If you set "CV" to "none", you're telling "GraphicalLassoCV" to skip cross-validation. In that case, you must manually provide the "alpha" value. It's like saying, I know the best "alpha", don't bother searching. This is absolutely true. Using cross-validation, when "CV" is greater than 1, helps find a better "alpha" because it evaluates the model across multiple subsets of the data. This makes the resulting precision matrix more robust and less likely to overfit the training data. It's a better generalization. This statement is correct. If I set "CV equals 5", GraphicalLassoCV uses 5-fold cross-validation. It splits the data into 5 parts, trains the model on 4 parts, and tests it on the remaining part, rotating which part is used for testing. The best "alpha" is chosen based on how well the model performs in this cross-validation process. I'm explaining Graphical Lasso cross-validation, GraphicalLassoCV, a scikit-learn tool for finding the best regularization parameter, alpha, for creating a sparse inverse covariance matrix, precision matrix. We use cross-validation to avoid overfitting. This question tests your understanding of how the CV parameter in GraphicalLassoCV controls cross-validation. I'll guide you through each statement to see which ones correctly describe the tool's behavior. If you set CV equals 5, you are telling GraphicalLassoCV to use 5-fold cross-validation. That means it will split your data into 5 groups, train the model on 4, test on 1, and repeat this process 5 times, each time using a different group for testing. This helps pick the alpha value that gives the best performance. Pretty neat. Setting CV equals none means that you're telling the model to skip the automatic cross-validation. You will need to manually provide the alpha value. Sounds simple, right? This statement is incorrect. The CV parameter isn't limited to integers. It can also take other scikit-learn cross-validation strategies like kfold or stratified kfold. Using cross-validation, CV greater than 1 generally creates more robust and less overfit precision matrix estimates because it uses multiple data splits to test the model's ability to generalize. This is better than using a single alpha value chosen without cross-validation. This refers to the dataset that GraphicalLassoCV uses. It's the starting point of the entire process, which is then processed to generate a covariance matrix, a matrix that contains the covariance between each pair of features in a dataset. This is the core machine learning algorithm used for sparse inverse covariance estimation. It uses the input data to estimate the inverse of the covariance matrix, precision matrix. The CV parameter in GraphicalLassoCV controls the cross-validation process. It determines how many folds or iterations are used to select the optimal regularization parameter, alpha. This is the sparse inverse covariance matrix, precision matrix, that GraphicalLassoCV outputs after estimating the optimal alpha parameter and processing the input data. This matrix shows the conditional dependencies between variables. The main goal of using GraphicalLassoCV in cross-validation is to find the best value for alpha, which is a hyperparameter that helps control the sparsity, number of non-zero elements, of the final precision matrix. By doing this, we create a matrix that is easier to interpret and reduces overfitting. I'm using this data to estimate a sparse inverse covariance matrix. Think of it like figuring out how different things in a system are related to each other, but only showing the strongest relationships. This data is the foundation for everything I do. This is how I check the accuracy of my model's ability to predict relationships. I do this by splitting the data and testing the model on data it hasn't seen before. It's like testing your knowledge with practice questions before a big exam. ensuring you're not just memorizing the answers. The number you see, like "CV equals 5", tells me how many times I repeat this process. In the context of GraphicalLassoCV, alpha is a parameter controlling how many relationships my model ignores. A large alpha means I am very strict, considering only very strong relationships, while a small alpha means I'm more lenient, incorporating even weaker relationships. Cross-validation helps me choose the best alpha value for accurate predictions. I want to be neither too strict nor too lenient. This is crucial to avoid overfitting or underfitting. This is the final result. It's a matrix that shows the relationships between variables in my input data, making it easier to understand the connections between different parts of the system. The sparse part means it focuses only on the strongest relationships, ignoring weaker connections to simplify analysis. I'm essentially constructing a map showing only the most important roads. This is the question I'm trying to answer. I'm testing my understanding of how this important function works. Let's get to work. That is the title of the problem. It essentially is a cross-validation analysis of a GraphicalLassoCV. I'm trying to understand how the CV parameter affects the performance of the graphical lasso model. This refers to the cross-validation parameter in Sklearn's GraphicalLassoCV function. Cross-validation is a technique I use to evaluate a model's performance and choose the best hyperparameters, which are settings that control the model. In this case, the hyperparameter is alpha, which controls how sparse the inverse covariance matrix is. A sparse matrix has many zero values. A less sparse matrix has more non-zero values. It's like choosing the right amount of ingredients for your recipe. Too few ingredients and the recipe fails. Too many ingredients and it becomes messy and complicated. This poses a multiple-choice question about how to interpret and use the CV parameter in the GraphicalLassoCV function. I will assess the validity of several statements about using cross-validation with GraphicalLassoCV. I'll decide whether each statement correctly describes how GraphicalLassoCV utilizes cross-validation. This statement says that setting the CV parameter to 5 means I'm doing 5-fold cross-validation. In 5-fold cross-validation, I split my data into 5 groups. I then train my model on 4 groups and test it on the remaining group. I repeat this process 5 times, each time using a different group for testing. I then combine the results to choose the alpha value that performs best across all folds. This states that setting CV to none will turn off cross-validation, meaning I need to provide the alpha value myself. I won't let the algorithm automatically determine it for me. This claims that CV can only be an integer. I need to know whether this is true. I will find that it's false. GraphicalLassoCV accepts other things too, not just integers. This suggests that using cross-validation, meaning CV is greater than 1, generally gives more reliable and less overfitted precision matrix estimates compared to not using it. CV equals none. Overfitting means a model learns the training data too well and performs poorly on new data. Cross-validation helps prevent this by evaluating how well the model generalizes. This indicates the multiple choice options given to answer the main question about GraphicalLassoCV SCV parameter. Hey Vamsi, we're diving into the exciting world of GraphicalLassoCV, a powerful tool from Sklearn that helps us estimate a sparse inverse covariance matrix. Think of it as figuring out the relationships between many different variables in a dataset, focusing only on the strongest links. Hyperparameter tuning means we're going to adjust some settings within GraphicalLassoCV to get the best possible results. This involves adjusting the alpha parameter, which controls how sparse the matrix is, and often using cross-validation CV to find the optimal alpha . This is the central question. We're focusing on how GraphicalLassoCV CV parameter, which controls cross-validation, works. Cross-validation is a technique to ensure our model generalizes well to unseen data and avoids overfitting. I'll explain this. Setting CV equals 5 means I'm splitting my data into 5 parts. Then, I train the model on 4 parts and test it on the remaining part. I repeat this process 5 times, each time using a different part as the test set. The result will be the alpha value that gives the best performance across all 5 tests. If I set CV equals none I'm telling GraphicalLassoCV I know the best alpha already, so I need to specify it myself. Cross-validation is skipped. This is incorrect. I can actually give CV more complex instructions. For instance, I can use predefined split methods for cross-validation. Integers are just one way to control cross-validation, not the only way. Using cross-validation, CV greater than 1, helps me to get a more reliable model that is less likely to be overfit, i.e., too specialized to my training data and not generalizing well. I get a more robust and reliable estimate of my precision matrix this way. The CV parameter dictates the method by which data is split. Model is trained and evaluated to optimize model parameters. The data is split according to the CV parameter. For instance, if CV equals 5 the data is divided into 5 folds. A model is trained on 4 folds, leaving out 1 fold for testing. The model is evaluated using the held out fold. This process is repeated for all folds. The optimal hyperparameters, alpha in this case, are chosen based on the performance across all folds.